Now, today we will see the idea of independent events. Now, the main idea here is that two events are considered independent when the occurrence of one event does not affect the occurrence of the other. What this means is that if you have two events, they will not affect each other. The probability of one event is not going to have any kind of effect on the probability of the second each other. And because they're not going to affect each other, then they will call an independent events. So again, here the main idea is when two events are independent, that is because the occurrence of one event is not going to affect the occurrence of the other event. So now let's start with just the core concept. Let's just look as to how we find the probability exactly. And again, here's in words, like two events, let's call that A and B, are independent if and only if the probability that those events to occur is the product of the probability of the events. Now, what this means is that if you want to find out the probability of two independent events, all you gotta do is multiply the probability of each of those events. So if you know the two events are independent from each other and you want to find out the probability of the overall case, all you gotta do is just multiply the probability of each of those cases. We will see some examples like this in a second, but first, let's concentrate if we can identify if we have independent events. So let's look at example A. Forget about B for a second here. So let's concentrate on A. Now let's see. Are the following events independent? Well, here's the scenario. We are going to toss a coin and it will show heads. And then you toss that same coin. Now, are those going to be independent events? Well, let's see. Well, usually pictures help. So imagine this is the coin and then you flip it. And now it lands as heads. So this is the ending of the first event. Now you're going to get that same coin and then you toss it again. But now this time it shows tails. Now let's see. That the first event, did that have any kind of effect for the outcome of the second event? Now again, notice here, like this arrow is just to point out that this is the tossing. So you get the coin, you toss it, and it lands heads. That's the end of the first event. Then you get the same coin, and then you toss it, and then it gets tails. Now, this is considered an independent event. This is an example of independent event because the first event did not affect anything at all as for the outcome of the second event. Because, I mean, it's the same coin. You're always going to have a 50-50. Here, you toss it, you get 50-50 to get heads. That's done. And the second chance is the same. You toss the same coin, and you have a 50-50 to obtain tails. So notice here that this is our independent event because it doesn't matter what the outcome of the first event was, you're still gonna get 50-50 fast for the second event. So that means that the first event did not affect at all for the second event. So because of that, this is an example of an independent event. So now let's look at example B. Here, we're going to randomly draw a name from a hat. So again, let's draw down some pictures here. So this is your hat. Okay, just use your imagination. That's a hat. Well, that's not really a hat. Um, cool. All right, so that's your hat. Now, okay, let's give it some. So that's your hat. So you're randomly gonna draw a name from a hat. So let's say you have a lot of names here. These are like papers with names on them inside your hat. And then without putting the first name back, you randomly draw a second name. Okay. So here's our head. We're gonna draw one of the names out. Let's say this is your head. We have five. Let's say we have five names in this head. So now let's say I pull out the first right here. Let's pull out this name. Now this is the end of the first event because you start with five names, you take one out. Now what do you have left? Well, here's our head again. Now how many names do we still got left? For now we have four now. Because you first start with five and you draw a name out. Let's say it's someone with the name of R. Here's your head. You got five names on it. You draw a name. So now you got four left. So now let's see. The first event, is this going to affect the outcome of the second event? Yes, it will, because you first start with five, and because you're not putting the name back into the hat, so now you reduce the number of names that are in the hat. So notice that the first event did had some kind of effect as for the second event. So this is not an independent event because the first example did had some kind of effect on the other. Because now here, because there were five, there's a 1 out of 5 chances of you to be taking out any of the names because you took one out. So now you have 1 out of 4 to name to take out any of those four names remaining. And if we do that again, then it's going to be 1 out of 3 because now there's going to be three names because you're not putting anything back. So this is an example of not an independent event because the first event did have some kind of an outcome as to what was going to happen on the second event. Because we started with five, you didn't put it back, so now we have four. So notice that the first event did affect the second event. So now that we're more comfortable with what independent and not independent is, let's actually start finding probabilities now. So now we're here. Let's look at example A again. And you might be familiar with this example. Now you toss a coin and it shows heads. Then you toss the coin again and it shows tails. Well, here we're gonna have two events. Again, P of A, P of B. P of A is gonna be what is the probability for us to have the first event. So now let's notice here. What is my first event? We're gonna toss a coin and it will show heads. So this is my first event. You tossing a coin and then showing heads. Now, what is the probability for you to toss a coin and show heads? That's 1/2 because you got a 50-50. Now, you're going to toss that same coin and now it will show tails. Now, what is the probability for us to be showing tails? It's still 1.5. But we know that these two events are independent. And because those two events are independent, then we can apply what we discussed here. If you want to find out the overall events and you know that there are independents, all we got to do, we just got to multiply the events. So now let's see. You want to find the probability for the following event, which is basically saying P, A, and B. According to what we saw previously, that's P of A times P of B. So that means that P of A is 1/2 times P of B is 1/2. So this is equal to 1/4. Because we knew that the events are independent, all we gotta do, we just gotta multiply their probabilities here. So now let's look at example 5. First thing they want to see is, well, are they independent or not? Because if they are, we can just multiply their probabilities and we will be done. Well, let's see. We're going to roll a 5 on a number cube, and then we're going to roll a 6. Well, let's see. Is this an example of an independent event? Yes, because it is kind of like the same idea as tossing a coin, but now instead of just dealing with two sides, we're dealing with six sides because you're going to be tossing the first row and then you're going to be tossing the second row. So notice that every time you toss the row, what happened previously is does not going to have any kind of effect as to what's going to happen next. So this is an example of an independent event. So if we want to find out the probability for the whole event, again, you need to know what P of A is, you need to know what P of B is, and then once we have that, we multiply them and we're done. So let's see, P of A, which is the first event. Now, here's the first event. We're going to roll a 5 on a number cube. Now, we know that a cube has six sides. It's just a regular cube that you know. So we have a cube that has six sides. Now, what is the probability for you to be landing a 5? Well, it's just one out of the six sides that are available. So we know that the probability for us to be landing a 5 is 1 out of 6. Now, what is the probability for us to be landing a 6 now? Again, 6 is just one of the many sides that a 6 cube has. So that means that the probability for us to be landing a 6 is just 1 out of 6 as well. So that means that since we know that they are independent, all we got to do is if we want to find the probability of independent events, all we got to do is just multiply their probabilities. So now we got 1 out of 6, which is the first one, times 1 out of 6, which is the second one. So that means that we got 1 out of 36. So we got 1 out of 36. If we want to have the scenario where we first going to be rolling a 5, and then you get your cube back, and then for you to be rolling it again, and then to land into a 6. You have 1 out of 36 chances for that scenario to happen. Now here's your entrance ticket. Identify if the following is an example of an independent event. So just let me know, is the following example independent or not?